Hi, I'm Isaac, a tutor at CWI, and today we're going to be working through practice exam number 2 for Physics 212. This is problem number 6. Let me get this out of the way. Alright, so this is a problem that has to do a little bit with resistance and resistivity and how differing sizes of materials, such as wires, can change the intrinsic resistivity. So the equation we'll need to know for this problem is that resistance is equal to the resistivity of the material times the length of the material divided by the cross-sectional area of the material. And the question says most telephone cables are made of copper wire of either 24 or 26 gauge. So we've got 24 gauge or 26 gauge. If the resistance of the 24 gauge wire, and this is, by the way, this is resistance per mile. Resistance per mile is 137 ohms per mile. And the 26 gauge is 220 ohms per mile. What is the ratio of the diameter of a 24 gauge wire to that of a 26 gauge wire? Alright, so first thing we're going to do is we're going to set up an equation. We're going to say resistance 1 equals rho times length 1, rho 1 times length 1 divided by A1. That's going to be for the 24 gauge wire, so I'll go ahead and notate that. And then for 2, resistance 2 is going to equal rho 2 times length 2 divided by the cross-sectional area of the 26 gauge wire. Alright, so one thing to notice right away is because these are resistances per mile, we can just go ahead and decide that L1 is going to equal L2, which is going to equal 1 mile. And that's going to save us a lot of trouble. So essentially for L1 and L2, those are just going to be 1. You'll notice if I times 137 ohms per mile by 1 mile, I'll just end up with 137 ohms. Likewise for the 220. And so for R2, it's going to be 220. For R1, it's going to be 137 ohms. I'm not going to write the units on this one. Resistivity 1 is copper, and so is resistivity 2. These are both copper wires. So we can go ahead and replace rho 1 with rho of copper, which is rho Cu, divided by area 1. And then for this one, it's 220 ohms is equal to the resistivity of copper, rho Cu, divided by A2. And this is going to come in handy. You won't actually need to know the resistivity of copper. Because we're making a ratio, those will actually cancel out. So what I'm going to go ahead and do is solve for area on both of these. So if I multiply A1 over and divide by 137, I'll end up with A1 is equal to rho over 137. And likewise, A2 is equal to rho over 220. Now, the commonalities here is that both A1 and A2 are circular cross-sections. So we can write this as pi R1 squared, that's the area of the cross-section of wire 1, is equal to rho over 137. And likewise over here, the area cross-sectional of wire 2 is going to be R2 squared, which is equal to rho over 220. Alright, the thing is it asks here what is the ratio of the diameter of the 24 gauge wire. And that's where we're just going to go ahead and ask ourselves a question, because we could go ahead and say that a radius is a diameter divided by 2. But let's look at these two wires. I'm going to draw them next to each other, not overlaid. So one of these is going to be R1. With gauges, the smaller the number, the bigger the wire. So the 24 gauge is going to be R1, and the 26 gauge is going to be R2. And you'll notice that if I double both R1 and R2, the ratio will actually maintain the same. So we don't actually need to put diameter where radius is, although you can if it makes you feel better. So essentially what I'm saying is that the ratio of radius 1 to radius 2 is going to be equivalent to diameter 1 over diameter 2. And so we can just go ahead and ignore that and stick with the R's. Alright, so I'm going to solve for R1 on this side and for R2 on that side. And so first thing I'm going to do is divide by pi. Rho over 137 pi. Then I take the square root. And that's going to be R1. And then over here I'm going to do the same thing. R2 is going to equal dividing pi from both sides and taking the square root. And the question specifically asks, what is the ratio of the diameter of the 24 gauge wire to that of the 26 gauge wire? So that means that the 24 gauge wire, or R1, is going to be on top of the ratio. So we're going to put R1, or the 24 gauge wire, over R2, or the 26 gauge wire. And that's going to give us our ratio. So we got R1 is rho over 137 pi. R2 is rho over 220 pi. Now you'll recall that you can actually put two square roots that are divided or multiplied. You can just write them as one big square root. And then what I'm going to go ahead and do here is multiply the top and bottom by 220 pi over rho, 220 pi over rho. And that's, of course, under the root as well. So I'm just multiplying by 1, by multiplying by this, so I'm not changing anything. But the rho's on the bottom cancel because they're both the resistivity of copper. 220 pi's cancel. The rho's on the top cancel because they're both the resistivity of copper. And what we're left with, let me make some room here. What we're left with here is that the ratio of the 24 gauge wire to the 22 gauge wire, which is R1 over R2, is equal to the square root of, let's see here, 220 pi over 137 pi. 220, and the pi's cancel. So 220 over 137. And that's our ratio, so let's go ahead and plug it in. Uh-oh. Well, for some reason I don't have my calculator on me, but I've got the answer written down here anyways. It's roughly 1.27. So the 24 gauge wire has roughly 1.27 times the diameter as the 26 gauge wire. So I actually looked up the difference in diameter between a true 24 and a 26 gauge, and it was more like 1.02. So I'm not sure if this is accurate. I'm pretty sure it's the right answer. So let me know what you got. Thanks. Bye.